Welcome to qnawire.
All right, here we have our function f of x equals x times the square root of 2 minus x squared. We want to find its derivative. So first I'm going to write it as x times 2 minus x squared to the 1/2 power. And then to find the derivative, we're going to use the product rule. So what we see here is the first times the derivative of the second. And when we take the derivative of the second, we're using the chain rule. So what we see here is the derivative of the 1/2 power part, the outside function. We bring down the 1/2 and we raise the inside to the negative 1/2. And then what we see here is the derivative of the inside. The derivative of negative x squared would be negative 2x. And then moving along, we have the second times the derivative of the first. The derivative of x is just 1. And then we can simplify that derivative a little bit. So what we can do is change our negative 1/2 power back to a radical and put it in the denominator since we have a negative power. We multiply the x, the 1/2, and the negative 2x, and that's where we get negative x squared. All right, so what we want to do for part B of the problem is put our original f of x as well as our f prime into the calculator, look at the graphs, and make sure they seem reasonable. So we grab a calculator, we go to y equals, we type f of x into y1, we type f prime of x into y2, and then for a window, I decided to try negative 3 to 3 on the x-axis and negative 6 to 6 on the y-axis. And here's what my graphs look like. So let's talk about why these make sense. So I'm going to trace along the graph of the original function f of x. Now notice as I move from left to right, f of x is decreasing, and notice that its derivative, which is in red, is negative. It makes sense for a derivative to be negative if a function is decreasing. Notice that right about here, the derivative is 0, so the red one is on the x-axis, and that's right about where the original function f of x would have a horizontal tangent line. Now we see that f of x is increasing. As we move from left to right, f of x is increasing, and we see the derivative, the red one, is positive. Right about here, we see the derivative is 0 again, and we see that is where f of x has a horizontal tangent line. And then now the original is decreasing again, and the derivative is negative again. So that all makes sense together.